So good afternoon to all. I'm Anvesh from AAA branch of seventh semester. So today is the topic is about the stability and its types. So the subject is the power system stability. So first of all, the power system stability. So the power system consists of some synchronous machine operating in synchronism for the continuity of the power system, and it is necessary that they should maintain perfect synchronism under all steady state conditions. When the disturbance occurs in the system develop a force which it become due to which it becomes a normal or stable. The ability of power system to return to its normal or stable condition after being disturbed it is called stability. So disturbances of the solar system may be various type like sudden changes of load. So the sudden short circuits become line and ground faults, all other line fault switching, etc. So the stability of the system mainly depended on the behavior of the synchronous machine after a disturbance. So the stability of the power system is mainly divided into the two types depending upon the magnitude of the disturbances. So the first one is steady state stability and the second one is transient state stability. So these are the two types of the stabilities that are steady state stabilities and the transient state stabilities. So furtherly they will be divided into some sub stabilities. So first of all, the steady state stability. So the steady state stability, it refers to the ability of the system to regain its synchronism. The speed, frequencies of all the network are same after slow and small disturbances which occurs due to the gradual power changes. Steady state stability is subdivided into two types. So that is a dynamic stability and static stability. So these are the two. So I've said you first, the steady state stability is subdivided into two types. So the first one is a dynamic stability and the second one is the static stability. So the dynamic stability. So the dynamic stability, it denotes the stability of a system to reach its stable condition after a very small disturbances. So disturbances occurred only for 10 to 30 seconds. So it also known as small signal stability. So it occurs barely due to fluctuations in the load and generation levels. So so it also known as small signal stability, and it occurs mainly due to the fluctuations in the load or generation level. So the static stability, so it refers to the stability of the system that obtains without the aid benefits of automatic control devices such as governors and the voltage regulators. So the transient stability, so it is defined as the ability of the power system to return to its normal conditions after a large disturbance. So the large disturbance occurs in the system due to the sudden removal of load, line switching operations, fault occurs in the system, sudden outage of a line, etc. Transient stability is conducted when new transmitting and generating system are planned. So the swing equation describes the behavior of a synchronous machine during the transient disturbances. So the transient and steady state disturbances occurs in the power system are shown in the graph below. So these are the disturbances reduce the synchronism of the machine and the system become unstable. So this is the graph I have said you. So this is the transient waves and the steady state wave. So when the wave and it is output. So when the wave is coming into transient wave, the middle, it is acting as a sinusoidal wave. It is reaching the maximum value of the output, and it also gradually decreasing, and then it is coming to the middle, and then it is going to the steady state wave. So it is the straight line to the steady state wave. So the output was a straight line to the output steady state wave. So another one is a rotor angle stability. So the rotor angle stability is the ability of interconnected synchronous machine of a power system to remain in synchronism after being subjected to a disturbance, ability to maintain synchronism under small disturbance. So since the disturbances are small, nonlinear, inertial equation can be linearized. So this is a midterm and long-term stability graph. So in this graph we can see there's a PE and PA, and there's a there's a critical angle, and there's a angle of reclosures. So there are the three waves that are that we are seeing in this graph. And there is an A1 and there is an area 2 which is covered with a delta naught and delta E, and there is a delta RE between the delta E and delta 2. There is a delta max. So there is a clear spike between the 0 to pi value. That's all. There is not there and there is nothing exceeding in this midterm and long-term stability. So this is a graph of the midterm and long-term stability. So if the power system exposures great or long lasting disturbance because of power flow frequency or voltage deviations, those disturbances are called server upsets. So the mid and long term stabilities are deeply related to the response of the system to those server upsets. So in this article, we we are discussing what the midterm and the long term stabilities are, how can they help in maintaining the system stable. So the difference between the midterm and the long-term stability. So those two concepts are newly in the stability definition of power system. So they are used because of need to analyze the dynamic response of system to serve upsets. So when the transition between transients and the long-term responses need to be presented in the midterm stability is used while long-term stability is used, slower and long-lasting mismatching between consumption and generating of both reactive and active powers is introduced, and it is vital that the power system is able to stand fractional rejection of load to minimize the effect servers upsets and restores ordinary power conditions. Deeper understanding of midterm and long-term stabilities, and we discussed the different power plants within the server upsets. So this is the graph over here. So this is the power system stability, though, that is divided to a steady state stability and the transient state stability. So the steady state stability is further divided into two types. So there is that is a dynamic stability, and another one is a static stability. So thank you.